To really understand networking, we need to understand all of the components involved. We're talking about everything from the cables that connect devices to each other to the protocols that these devices use to communicate. There are a bunch of models that help explain how network devices communicate, but in this course, we'll focus on a 5-layer model. By the end of this lesson, you'll be able to identify and describe each layer and what purpose it serves. Let's start at the bottom of our stack, where we have what's known as the physical layer. The physical layer is a lot like what it sounds. It represents the physical devices that interconnect computers. This includes the specifications for the networking cables and the connectors that join devices together, along with specifications describing how signals are sent over these connections. The second layer in our model is known as the data link layer. Some sources will call this layer the network interface or the network access layer. At this layer, we introduce our first protocols. While the physical layer is all about cabling, connectors, and sending signals, the data link layer is responsible for defining a common way of interpreting these signals so network devices can communicate. Lots of protocols exist at the data link layer, but the most common is known as Ethernet, although wireless technologies are becoming more and more popular. Beyond specifying physical layer attributes, the Ethernet standards also define a protocol responsible for getting data to nodes on the same network or link. The third layer, the network layer, is also sometimes called the internet layer. It's this layer that allows different networks to communicate with each other through devices known as routers. A collection of networks connected together through routers is an internetwork, the most famous of these being the internet. Hopefully you've heard of it. While the data link layer is responsible for getting data across a single link, the network layer is responsible for getting data delivered across a collection of networks. Think of when a device on your home network connects with a server on the internet. It's the network layer that helps get the data between these two locations. The most common protocol used at this layer is known as IP, or Internet Protocol. IP is the heart of the internet and most small networks around the world. Network software is usually divided into client and server categories, with the client application initiating a request for data and the server software answering the request across the network. A single node may be running multiple client or server applications. So you might run an email program and a web browser, both client applications, on your PC at the same time. And your email and web server might both run on the same server. Even so, emails end up in your email application and web pages end up in your web browser. That's because our next layer, the transport layer. While the network layer delivers data between two individual nodes, the transport layer sorts out which client and server programs are supposed to get that data. When you heard about our network layer protocol, IP, you may have thought of TCP IP, which is a pretty common phrase. That's because the protocol most commonly used in the fourth layer, the transport layer, is known as TCP, or Transmission Control Protocol. While often said together as the phrase TCP IP, to fully understand and troubleshoot networking issues, it's important to know that they're entirely different protocols serving different purposes. Other transport protocols also use IP to get around, including a protocol known as UDP, or User Datagram Protocol. The big difference between the two is that TCP provides mechanisms to ensure that data is reliably delivered, while UDP does not. Spoiler alert, we'll cover differences between the TCP and UDP transport protocols in more detail later. For now, it's important to know that the network layer, in our case IP, is responsible for getting data from one node to another. Also, remember that the transport layer, mostly TCP and UDP, is responsible for ensuring that data gets to the right applications running on those nodes. Last but not least, the fifth layer is known as the application layer. There are lots of different protocols at this layer, and as you might have guessed from the name, they're application specific. Protocols used to allow you to browse the web or send and receive email are some common ones. The protocols at play in the application layer will be most familiar to you, since they're ones you've probably interacted with directly before, even if you didn't realize it. You can think of layers like different aspects of a package being delivered. The physical layer is the delivery truck and the roads. The data link layer is how the delivery trucks get from one intersection to the next over and over. The network layer identifies which roads need to be taken to get from address A to address B. The transport layer ensures that the delivery driver knows how to knock on your door to tell you your package has arrived. and the application layer is the contents of the package itself.